Credit card fraud has become a significant issue, with substantial financial losses annually. To mitigate this, banks and financial institutions deploy fraud detection systems, which can be categorized into expert-driven, data-driven, or a combination of both. Data-driven methods, such as machine learning techniques, have been increasingly used to learn fraud patterns, but they often require a time-consuming training phase. The proposed Arrow method addresses this limitation by providing an efficient way to detect fraud without extensive training time. Arrow is a supervised method that aims to improve fraud detection effectiveness by sampling from the majority class, thereby enhancing recall and reducing the required training time. Credit card fraud can be categorized into application frauds and behavioral frauds, and fighting techniques against fraud become more significant as the number of frauds increases. Prevention and detection systems are the first and second layers to protect the system against fraud, respectively. An effective fraud detection system should identify a high percentage of fraudulent transactions while keeping the false alarm rate low to avoid user apathy. The Arrow method stands out for its ability to provide accurate results in a shorter time frame compared to other machine learning techniques. The paper presents a literature review on various methods, including supervised, unsupervised, and semi-supervised algorithms, and lists several data mining approaches used for fraud detection in Table 1. The Arrow model is compared to artificial immune systems, ICE, for faster and more accurate detection. The paper also reviews techniques such as neural networks, support vector machines, decision trees, and random forests, highlighting their strengths and limitations. Experimental results and analyses are presented, showcasing the Arrow method's ability to achieve the best cost in a short time, making it suitable for real-time fraud detection systems. Credit card fraud detection is a critical issue in financial institutions, with the primary goal of increasing accuracy, reducing detection time, and lowering costs. A comparison of various algorithms, including neural networks, NN, Bayesian networks, BN, support vector machines, SVM, K-nearest neighbors, KNN, decision trees, DT, fuzzy logic, artificial immune system, ICE, genetic algorithms, GA, and hidden Markov models, HMM, reveals that ICE performs the best overall. However, this paper proposes the use of asexual reproduction optimization, ARROW, for credit card fraud detection, which has several advantages over other algorithms, such as faster convergence, good exploration and exploitation rates, and no requirement for parameter settings. The Arrow algorithm is a supervised method that is inspired by the budding method of asexual reproduction, where a parent produces a smaller copy of itself called a bud. The bud is then mutated and evaluated using a fitting function. The fitting function is calculated using equations 1 and 2, which measure the distance between the normal and fraudulent transactions. The cut point is the best fitness achieved in the dataset. The mutation process is repeated until the parent fit is smaller than the cut point. The probability of mutation is calculated using equation 3, and the bud is mutated based on this probability. The value of the mutated bud is calculated using equation 4, which evaluates the fitness of the bud. The Arrow algorithm is compared with ICE, which has the highest performance among the existing algorithms. The results show that Arrow outperforms ICE in terms of speed, accuracy, and cost. Overall, Arrow is a promising approach for credit card fraud detection, offering a faster and more accurate solution than existing algorithms. The Arrow algorithm is applied to all records and features, with each record having a fraud or normal label. Notably, only the integer part of the chromosome is considered, and genes are not binary, containing integer numbers. The normal records are sampled, as the dataset is skewed towards normal transactions, and the number of normal transactions is significantly more than fraudulent transactions. This research explores the application of asexual reproduction optimization, ARROW, and artificial immune system, ICE, algorithms in detecting credit card fraud. The Arrow algorithm utilizes an asexual reproduction process, where a parent generates a bud that undergoes larva generation and selection until a suitable normal sample is identified. This process evaluates the distance between the record and both fraud and normal transactions, with higher fitness numbers indicating better records. The ICE algorithm draws inspiration from the human immune system, employing negative and clonal selection stages to create detectors called lymphocytes. These detectors react to non-self cells, such as viruses, and protect the body against them. In the context of credit card fraud detection, both non-self and self cells are considered vectors, and the training set is normalized before initializing parameters. Primary detectors are selected randomly from normal records, and their affinity is calculated using a distance function. A colony is expanded from these detectors, mutated, and the best mutated population is chosen to replicate the worst memory cells. This loop continues until a stop condition occurs, such as after 150 iterations. The dataset used for this study is from a Brazilian bank, with 3.74% of transactions being fraudulent. The dataset was split into 9 parts for training and testing. The fraud detection system was trained using both arrow and ICE methods, and the performance was evaluated using metrics such as sensitivity, precision, specificity, and accuracy. The results show that arrow outperforms ICE in terms of sensitivity, precision, specificity, and accuracy, with a significant increase in the area under the curve, AUC, of the ROC curve. Statistical tests were conducted to ensure the statistical significance of the results. The findings suggest that arrow is more effective for credit card fraud detection compared to ICE, particularly in terms of accuracy and AUC. This research paper presents a comparative analysis of 2 bio-inspired algorithms, Asexual Reproduction Optimization, ARO, and Artificial Immune System, ICE, for detecting credit card fraud. The study utilized a dataset from a Brazilian bank, evaluating the algorithms using metrics such as sensitivity, precision, specificity, accuracy, and area under the receiver operating characteristic curve, AUC. The results indicate that arrow outperforms ICE in all metrics, with an average sensitivity of 0.81 and precision of 0.39, compared to 0.65 and 0.25 for ICE. ARO also demonstrates a significantly shorter training time, averaging 6.25 seconds, making it more suitable for real-time fraud detection systems. The study highlights the limitations of the ICE method, particularly its need for hyperparameter tuning, which is not required in ARO. The findings suggest that ARO could be a promising alternative to traditional methods, offering better performance and faster processing times. The proposed framework for credit card fraud detection using Asexual Reproduction Optimization, ARO, addresses issues of high costs and training time. Future work includes testing the model in a cloud environment and comparing it with particle swarm optimization and quantum-behaved particle swarm optimization. The framework's potential can be improved by weighting transaction fields and using application-based distance functions. A comprehensive review of existing literature on credit card fraud detection highlights the significance of this issue and the need for effective methods. The authors suggest ARO as a promising approach, given its adaptability to changing transaction patterns. However, the framework requires further refinement and testing to ensure its effectiveness in real-world scenarios. The literature review emphasizes the diversity of techniques employed, including machine learning algorithms and optimization methods, and the importance of evaluating model performance using metrics like accuracy, precision, and recall. The authors present a comprehensive review of existing literature on credit card fraud detection, focusing on the application of various machine learning and optimization techniques. This includes the use of neural networks, hybrid models, evolutionary algorithms, and clustering algorithms to identify fraudulent patterns and improve detection accuracy. The surveyed papers demonstrate the effectiveness of these approaches in reducing false positives and achieving high accuracy rates, despite challenges such as the need for large datasets and the risk of overfitting. The research also highlights the importance of feature engineering and optimization techniques in enhancing the performance of fraud detection models. Asexual reproduction optimization is discussed as a promising approach to further improve the efficiency and accuracy of these systems. The paper emphasizes the limitations of current methods and the need for continued innovation and development in this field. The authors emphasize the potential of asexual reproduction optimization in enhancing the performance of fraud detection systems, particularly in optimizing model parameters and improving the robustness of these systems against evolving fraud patterns. They conclude by highlighting the importance of further research in this area to combat the growing threat of credit card fraud effectively.